Hello, today we will be covering 2.2 logic. We are going to start with a quick 5-minute check from 2.1. We're going to determine whether the conjecture is true or false. So we are given that angle 1 and angle 2 are supplementary angles. That just means that two angles add and equal 180. Now, our conjecture is that angle 1 and angle 2 are congruent. Now, based on the picture I just drew, two angles that are supplementary, these two angles are not congruent. They're also not to scale, but they're not congruent, right? So this means this conjecture is false, and a counterexample is one like I have drawn, that you can have one angle be 40 degrees and the other be 140 degrees. They are supplementary but not congruent. Okay, so our lesson today, 2.2, logic. You guys will be able to determine truth values of negations, conjunctions, and disjunctions and represent them using Venn diagrams, and you will be able to find counterexamples. So our new vocab is statement, truth value, negation, compound statement, conjunction, disjunction, and truth table. So part 1, we are going to determine truth values. A statement is a sentence that is either true or false. So any sentence I say is a statement. It could be true or false. Same thing here with these ones in our class. The truth value of a statement is either we mark it with the word true or a capital T, or false with a capital F. Statements are often represented using a letter such as P or Q. So in this case, this statement, a rectangle is a quadrilateral, is marked as statement P. It's just nifty to have shorthand. And a rectangle is a quadrilateral, so that is a truth value of T, or true. If we are going to negate a statement, the negation of a statement has the opposite meaning as well as the opposite truth value. So for example, the negation of the statement above is said to be not P, or shorthand, if you have a squiggle, that means the word not. Okay, so not P with the squiggle is the same. So not P in this example is a rectangle is now not a quadrilateral, and it has the opposite truth value of false. So if we join two or more statements by the word and or, this is a compound statement. It's going to feel a little more like English today than math class, to be honest. A compound statement using the word and is called a conjunction. So if we are compounding using and, that is conjunction. A conjunction is true only when both statements that form it are true. So this is also very important. Now, shorthand for the word and is actually a upside down V, or you can think of it as a capital A without the line. That is a conjunction. It means and. So if you see any of these words, they all work together. They mean the same thing. So we have an example. A rectangle is a quadrilateral. We already decided that had a truth value of true. We also have statement Q. A rectangle is convex. That is true. Convex just means the actual real definition is like a line cannot pass inside the shape, outside, and back into the shape. It is convex. If you have like a normal rectangle, concave is the other option, where if you drew a line, this line could pass into the shape, out of the shape, and back into the shape. That would be concave. I like to think of it as having a cave that I can stand in. Like I can go into the inside of the shape like that. Anyway, side note there. We're really just worried about the fact that that is a true statement. So if you make them a conjunction and just combine the two statements, a rectangle is a quadrilateral and a rectangle is convex, both of these are true. So if you have P and Q, this whole conjunction statement is true. So let's try a couple others. Use the following statement to write a compound statement for each expression. Then give its truth value. So what I like to do is I like to write the truth value of each one individually. 1 foot is 14 inches. Well, that's not true. 1 foot is 12 inches. September does have 30 days. And a plane is divided by 3 non-collinear points is also true. Okay? So now I know the truth value for each statement. All I do is write my P statement and my Q statement. So I have 1 foot is 14 inches. And because it's a conjunction, September has 30 days. So I know that this is a false statement and this is a true statement, but because both of them are not true, this conjunction is false. We can do a similar thing with the next one, but notice we now have a not, so we're going to have to make a not P statement. So we have R, a plane is defined by 3 non-collinear points and we have to have not P. You just add the word not in. 1 foot is not 14 inches. Now notice we have a truth value of true here for the R statement. And now because it's a negated version of P, the truth value is true for our second part as well. So our truth value of our whole compound statement is true. We can do that again. Another example. Go ahead and pause me if you want to try yourself. All right, here we go. So use the following statements to write a compound statement for the given expression, then state its truth value. So I'm going to, before I do that, state that June is the 6th month of the year. That is true. A square does not have 5 sides, so the next statement, a square has 5 sides, is false. A turtle is a bird is also false. So now let's write P and R, which, remember, they could have said P and R. This way means the same thing. So June is the 6th month of the year, and R, a turtle is a bird. Once again, we can say, okay, this one was true, but this next one is false. So that means our total compound statement is actually false. Part B is similar, except now it's not Q and not R. So a square does not have 5 sides, and a turtle is not a bird. So now that we've negated both of these, they were originally false, so they have become true. A square does not have 5 sides. A turtle is not a bird. So these have truth values of true, making our compound statement true. Okay, so that's for conjunctions. We're now going to look at disjunctions. A compound statement that uses the word or, this is a disjunction. Okay, just another word to mean or. It says Malik studies geometry. Malik studies chemistry, so P or Q. Malik studies geometry or Malik studies chemistry. A disjunction is true if at least one of the statements are true. So both of them do not have to be true. Only one has to be. Two can be. The only reason it's false is if neither of them are true. Now, shorthand for or is similar to the and shorthand, but now it looks like a V. Okay? So let's try the or statements. Use the statements to write a compound statement for each expression, then state its truth value. So before we start, AB is proper notation for segment AB is true. Centimeters are metric units. 9 is a prime number is false, because 9 can be divided by 3. So now our compound statement is going to be compounded by the word or instead of and. So we have AB is proper notation for segment AB. Or Q, centimeters are metric units. All right, so we have true and true here for both of these statements individually, which means that this or compound statement is also true. If we look at the next one, not Q or R, we have centimeters are not metric units. Or 9 is a prime number. Now notice, this one has become false now. And this one is false. This is the only time an or statement or a disjunction is false when compounded, is when both of the individual statements are false. If we do one more, we are going to use the following statement to write a compound statement for not Q or not R. So we have not Q, the V is or, not R. Then find the truth value. So first of all, P is an even number is true. A cow has 12 legs is false. And a triangle has 3 sides is true. So we're going to say, okay, we need to negate Q. So a cow does not have 12 legs. Or, we have to negate R as well. A triangle does not have 3 sides. Because both of these are negated, they are now both their opposite truth values. So this top one is now true. A cow truly does not have 12 legs. A triangle does not have 3 sides is false. But because it is an or statement versus an and statement, since one of them is true, the whole compound statement is true. If you look down here, this concept summary is just a little place to go to look at negation. It's shorthand, conjunction, and disjunction, the and or, and what they mean. Now, conjunctions need both statements true. This will give us a truth value of true. A disjunction needs at least one true statement for it to be a true compound statement. Okay? kind of part one. Part two then is using our logic to make something called a truth table. Now, if you're planning on studying computer science, you'll probably have to take a whole semester class about this sort of stuff. So this is just a nice intro. A convenient method for organizing the truth values of statements is to use a truth table. Truth tables can be used to determine truth values of negations and compound statements. So, truth tables, just an organizational tool. You can have a negation here, where you'll notice if you have the P, you have the possibility of true and false. And then the not version is just the opposite of the original. Conjunctions, I always make sure I get all my possibilities here. So if I have a P value of true, I can have a Q value of true, P value of true, Q value of false, and then also P value of false, Q value of true, and P value of false, Q value of false. And then we have an AND version of these. Notice that the only time that P and Q is true is when both P and Q are both true themselves. Everything else is false. A disjunction, on the other hand, you only need one or more of the two to be true to have the OR statement true. The only time it is false is if all of these statements are false. So let's construct a truth table for not P or Q. So you make columns with everything you're going to need. We have a heading of P, Q, not P, and then not P or Q. Then you're going to list all the possible combinations of the values for P and Q. You're going to use the values of P to determine the values of not P. And then you'll use the values of not P and the values of Q to find the values of not P or Q. So let's do that. Construct a truth table for not P or Q. I find it easiest to make half of my boxes in my first column true and half of them false. Then I do every other for the next. You'll notice it changes a little bit if we do a larger set. So now I have every possible combination. I have true, 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 false, false, true, and false, false. Then I need to do not P, which means I look at the P column and write down the opposite. False, false, true, true. And then to do not P or Q, I just look at not P and the Q columns and see when one or two of them are true. If both are false, that is my false conjunction, or disjunction, I mean. That's my false compound statement. And I finished my truth table. Okay, let's try another one. A little bigger this time. You'll see what I mean with how our pattern kind of changes a little bit. So we need to have P, Q, and R. Also not Q, since there's a not Q in the statement. And then we need not Q and R. And then our finish not P. And then parentheses not Q and R. So, once again, make half of my boxes in my first column trues. This is just to ensure that I get everything, every possible combination, because it could get kind of crazy. Then, since there is 4 trues, I'm going to do half of my boxes of Q true and the other half false, and then I repeat that again. And then to finish getting all of them, for my R column, I do every other true and false. Then I need to look at my Q column and negate it. So it's going to be false, false, true, true, false, false, true, true. From here, I look at my not Q and R. So I'm looking for both of them being true. So when it's an and, they both have to be true for our compound to be true. In this case, it is a conjunction. And then for my very last step, what it was asking me, I need to look at my not Q and R, and then my P column. And this time I just need one or the other to be true because it's an or statement. So I have true, I have true, I have true and true. Then I have a false, a true, and a false. So you'll notice we have a true here, true here. This one actually has both, true, and then true. All right. We can also use Venn diagrams. So disjunctions can also be illustrated using a Venn diagram. Consider the following statement. A student is studying algebra. A student is studying biology. So you can look at them and say, oh, a student over here is studying algebra. A student over here is studying biology. They could be studying both, but they're only in the Venn diagram if they're doing one of those three things. If they're not doing them, then they're out here in false land, not part of our disjunction. So the Venn diagram shows the number of students enrolled in Monique's dance school for tap, jazz, and ballet classes. How many students are enrolled in all three classes? Now you want to look at the intersection of all three. So only 9 students are enrolled in all three. Next one, how many students are enrolled in tap or ballet? Now, because it is or, we want to include all of tap and all of ballet. So we have tap or ballet would be all of these. So we want to go ahead and add 28 plus 17 plus 9 plus 13 plus 25 plus 29. Because these students are in tap or ballet, it is true that they might also be in jazz, but just they are also in tap or ballet. Now, if you do that addition, 28 plus 17 plus 9 plus 13 plus 25 plus 29 is actually equal to 121 students taking either tap or ballet. Maybe both, maybe also jazz, but at least tap or ballet. Now, how many students are enrolled in jazz and ballet but not tap? So the and means that they must take both. So when they take both, it's in this section here. They have jazz and ballet as classes. But notice it says not tap. Because these 9 students in here also take tap, they are not included in that amount. So we have 25 students that take both jazz and ballet, but not tap. Okay? If this one up here had said but not jazz, for a second, we'll think through this. If it said but not jazz, you would have the tap circle, that ballet circle, but anywhere where the jazz circle overlapped, you would not include those numbers. So if it said tap or ballet, but not jazz, it would have just been 28 plus 17 plus 29. That's not the case though. It's just tap or ballet, which means it was all of the numbers we added. The Venn diagram shows the number of students at Manhattan School that have dogs, cats, and birds as household pets. So our first question is, how many students in Manhattan School have a dog, a cat, or a bird? So what clues us in here is the fact that it says a dog, a cat, or a bird. Usually with ors, we would include everything within the dogs, everything within the cats, everything within the birds, but because it specifically says a dog, a cat, or a bird, we only want to look at the ones that they have a dog, a cat, or a bird, not where they possibly have both or all three. So we're actually just going to take 85 plus 110 plus 31, and we get 226 students. The next one is another one of those or ones, but it says how many students have dogs or cats. That just means we're looking at the whole circle for dogs and the whole circle for cats. So we're actually going to end up adding more things this time because they could have both. They could also possibly have birds because it doesn't say but not birds. So we're going to end up adding all of these things together, just making sure I got them all. So we have 85 plus 47 plus 23 plus 10 plus 110, and then add 5 to that, and we get a total of 280 students. And then how many students have dogs, cats, and birds as pets? That is just where we have it and. So we want to make sure we have all three of these as pets. So that's actually only 10 students that have all three. That is all I have for you today. Have a great day.